Reinforcing Sounds by Kordsa.
Welcome to Reinforcing Sounds podcast by Kordsa. We are talking wide-ranging conversation on future of everything, from tire and construction reinforcement to composite technologies in this channel. It's Aisha from Corporate Communication Department to moderate this episode. In this episode of Reinforcing Sounds, with 7 questions, we explain how and why composite materials can be a game changer. To discuss all these, we are together with Elif Erdoğan, who is Market Development Manager in Aerospace and Defense Industry, and Gemma, Technology Manager in Material Development. Welcome you both. Can you introduce yourselves for audiences, please? Ladies first.
Hello everyone, my name is Elif Erdoğan. I joined Kordsa 12 years ago. I have been working at Kordsa Composite business unit and holding market development manager position for aerospace and defense industries. Thank you for listening.
Thank you, Elif. And Gem?
Hello, this is Gemma. I've been working for Kordsa for 4 years. I started at the composite department from its start, and thank you.
In this episode, we are together with 2 experts, and thank you, both of you, for your participation in this episode of Reinforcing Sounds. I would like to ask my questions one by one. Core of our topic today is composites, as you know, and they are used in a wide variety of markets, as I know, but we are together with 2 experts today. I would like to ask Gem in first question, what are the uses of composite materials?
Yeah, composites can be used everywhere that needs waste saving and specific improvements that only composite structures are a solution. From aircraft jet engines to consumer sports goods, to blades of the wind turbines, parts of the electrical cars, and also some consumer electronics. It is literally everywhere, in many things that we use, and it touches our lives.
Yeah, really interesting. Actually, composites are everywhere, let's say, right?
Yeah.
Traditionally, materials such as iron, steel, and aluminium are used in these sectors you mentioned. What are the advantages and disadvantages we encounter when we want to use composites instead of those materials? What do you think about it? I asked both of you this question.
Advantages of use of composites are quite extensive, actually. We can summarize as lightweighting and new design possibilities and designable properties, and compared to the metals, it really reduces the work costs. Among the disadvantages that further limit the further spread of the composite usage are higher prices compared to the metals and some recyclability problems of thermoset composites.
Elif, what will you say about that?
Indeed, I totally agree with Jem. Lightweight is the biggest advantage of using composite materials. Another big advantage of composite materials is their design flexibility. They can be made into rough shapes. A single composite material with a strange shape can replace many other materials. This useful feature can reduce maintenance and therefore the cost of over the life of a part. And moreover, laminate patterns and ply build up in a part can be tailored to give the required mechanical properties in various directions. As a result of that, as the part count is reduced, it reduces the relatively higher production cost of the composite part. It can even be concluded complex double curvature parts with a smooth surface finish in one manufacturing operation. That's for sure. There are some deficiencies as well. For part manufacturers, the biggest disadvantage of composite materials may be the higher initial cost compared to metals. The higher cost is mainly due to the price of the fiber. Secondly, the intermediate materials like prepregs requires refrigerated transport and storage and have limited shelf lives. And lastly, for the applications requiring conductivity, composite materials cannot meet the requirements. However, this problem can be immediately solved by incorporating wire mesh into the structures. And taking all into account, composite materials bring definite benefit to the parts, companies, and the users, I believe.
Let me clarify all these. You say that advantages of the composites are lightness, low fuel consumption due to lightweight and its strength, smooth surfaces for aerodynamics, and chance to produce complex part in one production process, right? And disadvantages of composites are the expensiveness, let's say, and as I know, replacing instead of repairing, I think, because the composite materials produce as one part, and so you can not repair the part, but maybe you can replace the part. Also, some requirements in the supply chain, like you say, in refrigerating transportation. So these are the advantages and disadvantages, all the composites. So why composite materials widely used in aviation? There's a saying that composite materials can change the aviation industry. How are composite materials changing the aviation industry, Elif?
The most obvious and significant benefit is reduced weight and high strength of the finished aircraft. As we all know, the composite materials are used across industries, providing added advantage of stiffness while being less heavy. Out of all these industries, one sector that has been benefited extremely using composite materials is the aviation industry. As airplanes need to carry passengers and staffs through the aerial mode, they are required to be highly durable and strong. And every aircraft has a certain weight carrying limitation that it can withhold up in the pressure. And this is where the need of a higher lightness need and stronger material need arises. What's more, lightweight aircraft are more fuel efficient because it requires less fuel to propel the fuselage forward. The strength of composite materials is also incredible, so the strength to weight ratio is higher than the metal used to make aircrafts. In addition to that, composite materials are not easily corroded by the irritating chemicals that are resistant to many highly reactive chemicals. They can also cope with various temperature changes and exposure to severe weather conditions. That means once the composite structure is formed, it will remain its shape and size. This is very important in the aircraft industry because it means that the critical parts of aircraft made of composite materials will not grow, shrink, or deform as environmental conditions change. Thus, these with these advantages in front of us, it's hard to avoid and not leverage the benefits of composite materials offered to the aviation sector.
Yeah, it's really interesting actually, because in aviation we are talking about lots of components, from parts to non-technical things, but the composites, I think, provides us lots of advantages in aviation sector. But the aviation industry is in a turmoil, and the COVID-19 still affects the industry. For example, I personally don't feel comfortable about the travel by plane. I'm sure you remember the Jetsons animated sitcom and their flying cars. Will we see flying cars around? I mean, what should the future of aviation look like? When will airlines recover?
Uh, with only a few weeks left until the end of 2020, and the aviation industry needs to pick itself up and begin rebuilding. In less than 12 months, the COVID 19 pandemic has emptied its pockets and wiped out passenger numbers, leaving it vulnerable to a global economic recession and in desperate need of recovery. And a nice question appears everywhere. What should be a 5-year plan for aviation industry look like? And building on that, presuming passenger numbers bounce back and growth returns to the agenda. I think, in my opinion, we will never go back to the same normal we had before. So the industry will need to adapt in the same way it did before for September 11 attack, and its new security standards. It should be adapted to new standards. That's for sure. Hygiene and health standards will need to change too in the near future. And airlines and airports need to adopt new safety measures to meet the new health requirements being introduced to reduce hand contact in the airport, ensure social distancing, and remove some services from the airports to reduce the congestion. Moreover, the industry is expected to recover globally around early or mid 2023. However, certain parts of the world will recover only in 2024 or 2025. In general, the industry will need to demonstrate to its customers that they remain a safe industry. Giving travelers the confidence to fly will be crucial. The industry will need to focus on resilience in the face of possible future pandemics as well. Moreover, I think starting now, industry must work to bring to market solutions to improve data sharing between airlines, airports, and other stakeholders to manage passenger flows and sanitary measures. Today, unfortunately, many passengers are still experiencing frustrating refund delays. If the airlines are to restore the customer confidence in the aviation industry, they need to make the passengers feel like governments, airlines, and travel companies are on their side. These are my opinion for the recovery.
Yeah. At the beginning of my question, I asked you to fly in cars, but maybe in the near future we can talk about the drones. When do you think that the drones will become our daily life like career?
As you know, drones, remote controlled aircraft or missiles, also referred to as unmanned aircraft vehicles. They have been used by the military for years, but recently there has been an increase in flying drones for commercial use as well. And the Federal Aviation Administration now allows companies to apply for certificates that allow them to fly civil drones for research and development, including for agricultural and real estate purposes. And now, most popularly, as you may all know, Amazon is working on Prime Air as a feature delivery system. It's designed to safely get packages to customers in 30 minutes or less using drone delivery. Although Prime Air is not ready to launch yet, I'm sure this drone delivery service will bring the major challenges itself. And commercial use of drones will be a changer for sure. However, this game changer is the least truly predictable for the potential impacts of drone delivery, I think. Clearly, in my opinion, a world that features drones buzzing about the streets is not the world we live in now. These are uh, these are still valid questions. How many drones will Amazon or its competitors deploy? How often will drone delivery be used? Will noise be a problem? Will they ever crash? And anything could happen, and only time will tell us.
I'm really excited about the drones, but also afraid of hitting my head to one of them. If they will use for commercial purposes, they will be all around.
Yeah, definitely. I think this is the main question of the people, because the commercial use of drones is something that not everyone is comfortable with. Many drones today, especially those used by the military, are controlled by human pilots. Those pilots may be many miles away, but they go through complex training to learn how to control the drone device and what to do if something goes wrong. All indications are that commercial drone delivery will be automated. No further human intervention necessary. Yeah, that's reason why uh, even when it's have been shown that automation produces a safer version of some previously human-driven activity, not everyone trusts computers and their algorithms. Yeah, this is the point that you have touched.
At this point, we can understand that composites share is also important in the future of aviation industry. Moreover, what we think of as science fiction is not far away. Okay, let's a little bit look at the composites techniques. Composites can be produced with several methods, and Kordsa is highly specialized on prepreg production. What are the advantages of prepreg production compared to resin transfer molding?
Yeah. Main production method with prepregs is actual autoclave molding, and we can think of it as an analogous to pressurized cooking. And prepregs are laid up, then bagged with special films and subjected to vacuum. At the same time, in pressurized ovens, subjected to heat and pressure. When the curing completes, the pressure is released and cooling starts with the follow of demolding of composite parts. And one of the competitive methods is resin transfer molding, which is also called as RTM, and in composite production. In this method, dry fiber mats are placed in molds, then molds are closed, and certain types of the mold vacuum is applied through the vacuum ports, and from the certain uh, ports, resin injection is applied. When the mold cavity with dry fibers are completely wetted out and the whole cavity is filled with the resin, vacuum ports are sealed and injection stops. Then the curing starts. When the curing completes, the mold is opened and part is demolded. The difference between them is that, but their results are actually quite different. Using the prepreg production of composites give many advantages compared to the other alternatives, such as higher fiber content, which translate to the higher mechanical properties, more control over homogeneity and consistency of fiber to resin ratios, and it is distribution all over the composite bodies. Advantage of competitive composite part manufacturing methods like RTM are actually resulting of cheaper production with the disadvantage of the lower mechanical properties and less control on homogeneity and consistency of fiber to resin ratios. Autoclave actually is a costly equipment compared to the ovens used in composite manufacture of prepregs. And autoclave consumes pure nitrogen in order to create required elevated pressures. And in curing, one also has to heat all the nitrogen gas inside it at high pressures, usually consumes 94% of the energy used in autoclave molding. And thus, autoclave molding is a costly technique in both price-wise and environmental-wise. Oven-curable prepregs, as a new development, represent an emerging class of prepreg materials designed specifically to be cured in an oven with only vacuum-bag processing, without the added applied positive pressures like in autoclave curing. Thus, oven curing neither does need the nitrogen gas, nor high energy impulse, nor the high equipment cost. With the help of new generation autoclave curable prepreg systems, we are able to achieve very low void levels and high mechanical properties similar to autoclave cured prepregs. And with the absence of autoclave molding, autoclave prepreg processing is seen as an attractive processing alternative for production of large high-quality composite structures. Further, there are multiple variations of autoclave processes that can be fine-tuned for specific applications and demands of the customer, and the performance to cost ratio is moving toward what is required for a sustainable growth in composite industry.
In Kordsa, we are developing both for autoclave and out of autoclave prepregs, right?
Yeah, you are true. We are both developing both of these. Yeah.
We actually all know about what is prepreg. Can you clarify what the prepreg is?
Prepreg is actually, it implies its name. It means that the fiber is pre-impregnated with the resin system. So it is coated with resin and it is ready to use actually. All you have to store in the coat, and before the use you have to heat it up at the room temperature, then it becomes flexible again and you can use it inside the molds.
As a communication specialist, what I see is that a kind of fabric that a bit wet and sticky, right?
Yeah, it a bit looks like a scotch tape actually. It is a bit sticky.
Yeah, it's a bit sticky and wet, and we can produce any kind of part with the sticky thing through autoclave or autoclave processes.
Yes, you are correct.
Okay, thank you. I feel smart to be able to make this clarification. All right, final question. In this episode, with 7 questions, we place composites as a game changer. All we know that through digitalization and transformation, every sector is changing. New technologies and new material alternatives widen our horizons. So when do you think the composites will be used widely?
In my opinion, it will be the use of composite materials for automotive industry will become more popular with the use of electrical vehicles. And lightweight design and electrified powertrain have become important strategies in automotive industry, as you all know, in order to reduce fuel demand and break down emissions respectively. And lightweighting of electrical vehicles is considered a step forward because advantages of both electrical vehicles and lightweight design could be combined to reduce environmental impacts even further thanks to the use of composites.
Okay, Jem, what's your answer in this point of view?
With the help of evolving robotic and digital manufacturing techniques used in composite part production, will finally reach the production speeds and consistency needs in commercial car production. All of these new developments with the requirements of the emission reduction targets that Elif mentioned, and also reduction of environmental impacts and sustainability targets that are mainly demanded by European Union. And all these new developments will finally open the door for the new composite solution in car industry,
Okay.
I think.
With this conversation, I think we definitely put the composites in a game changer position. Thanks both of you for your participation, Jem and Elif. See you at next episodes of Reinforcing Sounds.
Reinforcing Sounds by Kordsa.